All right, today we want to be able to graph reciprocal functions and their transformations. Now that begs to ask the question, what is a reciprocal function? Well, the easiest type of reciprocal function is f of x equals 1 over x. And now if we wanted to create a table of values to kind of take a look at what the graph looks like, we could go x and f of x. If x equals 1, f of x is 1. If x equals negative 1, f of x is negative 1. If x is 2, f of x is 1/2. If x is 1/2, f of x is 2. And similarly, if x is negative 1/2, f of x is negative 2. Now, if we wanted to go ahead and sketch the graph of this thing, we can come over here, set up a set of coordinate axes. I don't draw any better on here than I do on the smartboard. Now, we'd have a point at 1, 1, 1/2, 2, and so forth and so on. But what you would see is that we'd have a graph that looked kind of like that. And then we'd have another branch over here for the negative x values. Now, again, asymptotes is the y-axis and the x-axis. So for your basic reciprocal function, f of x equals 1 over x, we just have this graph in the first quadrant and another branch in the second, right? We got branches in the third quadrant. Right. When x is positive, f of x is positive. If x is negative, f of x is negative. But now, we could go ahead and we could graph these things over and over and over again, but that'd get a little boring. I mean, we could take a look at things like, well, what happens if f of x is equal to 2 over x, right? What do you think's going to happen? Well, I'm kind of thinking that it's going to get a little farther away from the origin, but it's going to maintain the same general shape. Okay? The bigger the numerator is, the farther it gets to the origin, and likewise, if I'd had some sort of rational number up on top here, like a 1/2, I'd get closer to the origin. That's like a scale factor, right? It makes it fat or skinny. The bigger number makes it skinny. If you want to think about it that way, the smaller number makes it skinny, the bigger number makes it fat. That's how to think about that. Now, what if we had f of x equals negative 1 over x? Well, that just takes our branches and it flips them. Okay? Now, what we could do is look at a general form of a reciprocal function. F of x is equal to a over x minus h plus k, but a, h, and k are all constants. Okay? Now remember that this h would tell us which way, how far we slide left and right. And the K would tell us how far we slide up and down, and the A would tell us how fat or skinny our graph is. Now, if we take a look at a nice little easy one, f of x equals 1, I'm going to let 1 over x minus 2 plus 3. So if I came down here and I set up my coordinate axes, now this minus 2 means I move 2 to the right. So my vertical axis would look like this. The 3 tells me that I should slide 3 up, 1, 2, 3. And I'd have a horizontal axis right about there. So those are our asymptotes, and what we've really done is taken our origin from here and put it right there. Now all we need to do is look at that constant on top, and it's a 1, so this looks like a standard inverse function, and we just treat those asymptotes like they're the x and y axis. And it looks just like that. That's all you need to do. Let's do one more. Oh, hang on. Technical difficulties. Wait. All right, now let's try another one. Oh, and thank you, Megan, for not yelling at me. F of x equals, I'm going to stick with 1 over x plus 3 minus 4. So what I'm going to do is I'm going to come over here, and there's a y-axis, there's an x-axis. Plus 3 tells me I move 3 to the left, 1, 2, 3, and I got an asymptote. Minus 4 tells me that I move down 4, 1, 2, 3, 4, and right about there. You got to use some imagination to see that it's straight. And now what I do is I just sketch the branches in. And it looks like that. And that. And that concludes today's video. Please take some notes on this. If you have questions, bring them tomorrow and we'll work some more problems. Thank you.